This is Geometry Academy by Anli Liu. Our story revolves around Baoji, who is a boy who loves geometry. One day after school, he decided to play a math game, where in the math game, two people were given a problem, and whoever solved the problem correctly won. Now, the category he was playing in was factoring a square. Baoji factored the square slowly and did it in his head and got 11 and won. Now his opponent did the same exact thing, but instead he got 11 and -1. In the end, Baoji was the correct winner, and all of a sudden, Baoji's screen popped up with a message saying congratulations 1000 wins. Apparently, Baoji was the first person in the world to get 1000 wins playing in the math game. Then he found out that the first person to 1000 wins would get a free scholarship to Geometry Academy. Baoji became a local hero. He was the first person to do so, and he was sent an interviewer from school to interview him. The interviewer asked, how do you do proofs? Baoji then said that he would give the honor to his teacher, Mr. Morrison, to teach everyone how to do proofs. He then told everyone that doing proofs would involve a T shape. The statement would be on the left side of the T, and the justification would be on the right. Then he went on and did his favorite proof of proving two triangles congruent. Then Baoji was sent off to Geometry Academy. At first, Baoji was very scared, and his parents told him to look for geometry wherever in the school, and that would actually make him happy. So Baoji took their advice, and as soon as he saw the school with its big dormitory around him, he began looking for geometry. Baoji saw that he could make parallel lines from the school's outside building. In his mind, he imagined constructing two parallel lines using the windows as a template. Then, Baoji imagined a transversal cutting through the two parallel lines. The transversal cut between the two parallel lines created 8 angles. There are vertical angles, which are angles that share the same vertex, such as 1 and 4, which are congruent. Alternate interior angles, which are also congruent, such as 5 and 4. And there's alternate exterior angles, which are also congruent, angles 1 and 8. And also same-side interior angles, where same-side interior angles are supplementary, such as angles 6 and 4. Baoji then also saw that he could have made perpendicular lines in the school outside building. In his mind, he visualized constructing two perpendicular lines. If two lines are perpendicular to each other, they intersect at a right angle. It was time for Baoji to move into his new room. In his room, there was a circular window. He then looked at the window for any signs of geometry he could find. He then realized he could have made a right triangle with the circular window. A right triangle is a triangle with a right angle. When Baoji began thinking of right triangles, he then began to think of trigonometry ratios, such as sine, cosine, or tangent. Sine is the opposite side measure over the hypotenuse side measure. Cosine is the adjacent side measure over the hypotenuse side measure, while tan is the opposite side measure over the adjacent side measure. Using a ruler, Baoji then found that the legs of the triangle were 12 centimeters. He then decided to solve for the hypotenuse if y was 45 degrees. He then wrote out an equation using sine because he knew the opposite side length. Baoji then solved the equation and found that a was around 17 centimeters, which meant that the hypotenuse was also around 17 centimeters. There are also reciprocals of sine, cosine, and tangent. Cosecant, which is hypotenuse over opposite, secant, which is hypotenuse over adjacent, and cotangent, which is adjacent over opposite. We can also use inverses to reverse trigonometry ratios. Baoji also decided to solve for x, because he knew the adjacent side length and the hypotenuse side length. He then found that x was around 45 degrees. Baoji realized that whenever he looked for geometry in this new school, he would always feel happy. But then, classes began. The teacher noticed that Baoji was very nervous, so she called him up and began to teach him about if-then statements about Geometry Academy. If you work diligently, then you belong in Geometry Academy. If you love geometry, then learning geometry is easy for you. They then went over the converses of these statements. If you belong in Geometry Academy, then you study hard and work diligently, which is true. If learning geometry is easy for you, then you love geometry, which is false. After that, Baoji began to look less nervous in class. Baoji was walking around. After that, Baoji began to look way less nervous in class. Then, after school, he was walking in the halls and he saw an announcement. It read that the Academy recently hosted a bake sale where cookies were 50 cents while soda was 75 cents. Overall, 56 cookies and cans of soda were sold, and the school made $34.50. However, the records of the amounts of cookies sold were lost. The school needs to know how many cookies were sold during the bake sale as soon as possible. The first person with the correct answer will get a free lunch. Please email any answers to Mrs. Johnson. Baoji saw this and began working immediately. He first set out a system of equations for the amount of cookies sold and the amount of soda sold. Then he solved for x and then plugged in the x value into his first equation. Then he found out that the bake sale sold 30 cookies. After emailing Mrs. Johnson, he got a free lunch. At the school food court, Baoji decided to get a sandwich. As he was eating, a little boy named Johnny came up to him and asked, "Why is my sandwich much smaller than yours?" Baoji then used this opportunity to discuss more geometry in Geometry Academy. Looking at the sandwiches, he set up values for the sides. He then made ratios and proportions of the values so he could solve for the lengths of Johnny's little sandwich. 12:6 is a ratio, which is a scale comparing the lengths of the two sandwiches. 8:x equals 2:1 is a proportion, which is two ratios set equal to each other. In order to solve proportions such as AB equals CD, AD must equal BC. Baoji taught this lesson to Johnny. Baoji then solved for y, which was 10. There are four properties of proportions. If AB equals CD is a proportion, then AD equals BC is also a proportion. If AB equals CD and is a proportion, then both DB equals CA and AC equals BD are proportions too. If AB equals CD, then BA is equal to DC. If AB equals CD, then A plus B over B is equal to C plus D over D, or A minus B over B is equal to C minus D over D. Baoji then showed all these properties to Johnny with the lengths of their sandwiches. In order for two polygons to be similar, the ratios of the lengths of their corresponding sides must be proportional. Baoji taught this to Johnny and said that their sandwiches were similar. He then said that polygons can also be proved similar if they contain two congruent angles, angle-angle similarity, or one proportional side, congruent angle, and another proportional side, which is side-angle-side similarity. Similar polygons contain proportional sides and congruent corresponding angles. Baoji was very happy when he explained all of this to Johnny, and Johnny was too. Johnny said, "Wow, I never knew there was all this geometry in our common day lives." Baljeet then began to walk with Johnny in school. One day, they saw a quarter on the ground. Baljeet then used this opportunity to describe Johnny about unit circles. He said that unit circles are circles with a radius of 1. If xy is a point on the unit circle's circumference, then absolute x and absolute y are the lengths of the legs of a right triangle whose hypotenuse has length 1. Johnny realized that this was another example that Baljeet used to find geometry in common-day life. Then, again in the hallway, Baljeet saw another announcement asking for help. The construction workers for the new academy garden has lost their blueprints. Luckily, one of the workers remembered that the length of one side of the rectangle garden was 3 feet less than the other side. A different worker also remembered the garden was to be 54 feet squared. The workers need to know the lengths of the garden. Email any answers to Mr. Jacobson. The first to do so will get a free trip of the construction of the new garden. After seeing this, Baljeet knew that he needed to bring Johnny along. Together, they worked together to find the new lengths of the garden. Baljeet then made a quadratic equation of the garden lengths. He then factored it and found that the length of the long side of the garden was supposed to be 9 feet. After emailing Mr. Jacobson, Baljeet and Johnny got a free trip to view the construction of the school's new garden. They started at the north side of the garden. Baljeet then told Johnny about interior angles after seeing a lake and the bridges. An inscribed angle is an angle formed by 2 chords in a circle with a common vertex. The angle measure is always half of its arc measure. If the arc measure is 100 degrees, then the angle measure is 50 degrees. Then they went to the center of the garden. Baljeet then taught Johnny about interior angles, which is an angle where its vertex is at the intersection of 2 lines inside of a circle. In order to find the angle measure, the sum of the arc measures created divided by 2 is the angle measure. If the measure of one arc is 150 degrees and the other arc is 50 degrees, then the angle measure is 100 degrees. Then they moved on to the east side of the garden. Baljeet then saw exterior angles and decided to teach Johnny about it. An exterior angle is an angle that has a vertex outside of the circle and its sides are made up of secants or tangents. In order to find the measure of an exterior angle, the difference between the 2 arcs created divided by 2 is the angle measure. If the measure of one arc is 100 degrees and the measure of the other arc created is 20 degrees, the measure of the exterior angle is 40 degrees. Baljeet then set up variables for the bridge lengths. If 2 secants share an endpoint outside of a circle, then the product of the length of one secant segment and the length of its external segment equals the product of the length of the other secant segment and the length of the external segment. This means that 3 times 3 plus x is equal to 2 times 2 plus 7. Baljeet told this to Johnny and together they solved for x, which turned out to be 3. A secant is a line that intersects a circle twice. They then moved on to the south side of the garden. Baljeet constructed an inscribed circle using the angle bisectors of 2 angles of the triangle. He then told Johnny that this is an inscribed circle. The circle is inscribed inside of the triangle, and the center of the circle is the triangle's incenter. Baljeet then constructed perpendicular bisectors of the other triangle. This formed a circumcenter, which he then circumscribed the circle around of the triangle. He then told Johnny that this is a circumscribed circle. The circle is circumscribed around the triangle. The center of the circle is the triangle's circumcenter. Baljeet then told Johnny that if a secant and a tangent intersect at a point of tangency, the angle formed is half of the measure of the intercepted arc. If the arc measure is 180 degrees, then the angle measure is 90 degrees. Baljeet then set up variables for the bridges intersecting in the middle of the lake. He then told Johnny that if two lines intersect in a circle, the product of the segments of one line is equal to the product of the segments of the other. This means that 6 times 4 is equal to 8 times x, which then means that x is equal to 3. Baljeet then set up variables for another lake. He then told Johnny that a tangent is a line that intersects a circle at one point. It is always perpendicular to its radius of a circle. If a secant and the tangent share an endpoint outside a circle, then the product of the length of the secant and the length of its external segment equals the square of the length of the tangent. This means that 4 squared is equal to 2 times 2 plus x. Johnny solved and then found that x is equal to 6. Baljeet then told Johnny that if two tangents from the same extensive point are tangent to the same circle, the tangents are congruent. After their trip, Johnny and Baljeet became best friends. Together, they would look for geometry in their everyday lives at Geometry Academy. And while doing this, it strengthened their relationship together, and they both grew as friends.